Okay, so we are now working on problem number 13. Please follow along as I read the problem aloud. Rami designed a small pond with a waterfall for a restaurant. The diagram shows the measurements of the pond. How many cubic feet of water are needed to fill the pond? So again, I'm going to start off with my sentence. Okay, so I have my sentence. The pond needs feet cubed of water. Now, I did try to draw a drawing, so I did my best with that. But you can see that the pond has that overhang. So when we take a look at this, we have to divide this up into two rectangular prisms because right now we only know how to find the volume of rectangular prisms using the formula. So we can divide this in different ways. I am going to choose to divide it where it's going straight down. So I have my prism A here, and then my smaller prism B here. Okay? So I need to find the measurements for each one of these prisms. So I'm going to stop and label my diagram so it matches yours. So now I've added my measurements. So when I take a look at prism A, so I'm going to first find the volume of prism A. So I remember that the volume formula is the area of the base, which is length times width times the height. Okay? So when I take a look at A, I'm given two measurements. I can see those two measurements very easily. I can see that for prism A, I can call this the length, and I can call this the height. Okay? Now, I need to find what that width is. So when I look at prism A, I can see that right here on prism A will be my width. Well, I need to figure out, it doesn't give me that information. So I need to figure out what that is by looking at my diagram and thinking back to the blocks when Mrs. Schreck was building the prisms for you. Remember, we can follow it through, and we can see any line that is parallel to this will help us to figure it out. So if I look around, I can see that this 6 feet will match that. The top smaller prism will be the same width as that bottom larger prism, or the bigger prism. So now I know that this will be my width. So I can go ahead and substitute my numbers into my formula because I have my formula. Now I need to substitute. My length is 12 times, notice the dot for multiplication, 12 times 6 times my height, which is 4. So I can do my work off to the side. When I multiply 12 times 6, I'm going to get 72. And then 72 times 4 is going to give me 288. So the volume of the first prism is 288 cubic feet. Notice the 3 is after the unit. So now I need to figure out the volume of prism B, which is the smaller one. And I found that width, and remember we talked about how that width is going to be matching. Okay, it's going to match A. I can also see that the height of that prism is 2 feet. So now what I need to be able to find, and I'm going to change colors here, I need to know how big this is. Actually, I'll change to orange so you can see it even better. I need to know how big that dimension is. Well, it doesn't give it to me. But I do have the 18 feet that will help me and the 12 feet. Remember that I know that this part for prism A is going to be 12 feet. Okay? Because it's a rectangular prism, all of those edges that are parallel are going to be the same length. So now, to figure out this part right here, I can do 18 minus 12, which would give me 6. So I now know that my length for prism B is 6. So now I can take my formula. Oops. I can take my formula. Remember, it's the area of the base. I'm thinking area of the base, but I'm writing length times width because that's how I'll find the area of that rectangle. And then, oops, do a little V equals. We know that we need to substitute, and we're going to substitute in 6 for the length, times 6 for the width, times 2 for the height. So I know that 6 times 6 is 36, and I need to multiply 36 times 2. I get volume is 72 cubic feet. So the volume of prism B is 72 cubic feet. I now need to add, and I'll do it right up here, 288 plus 72. 8 and 2 is 10. Carry the 1. 8 plus 1 is 9, plus 7 is 16. Carry the 1. And I get 360 cubic feet. 360 cubic feet. That pond needs 360 cubic feet of water. So I can stop and think, and it does seem reasonable that that's how much water given those dimensions.